So now we are going to actually start to develop permutations in much more depth. We're actually going to work towards having a general mathematical expression for given permutations. And we're going to do that in the context of one of the very common permutation style questions, populating a committee. So imagine we have 12 people, and there are 5 unique roles to fill on a committee of these 12. So it could be president, vice president, treasurer, secretary, right? We've got our 5 roles here. We need to ask ourselves, how many ways are there to populate this committee? Well, the fundamental counting principle says, well, first role, you've got 12 choices. When you're filling in the second role, however, someone's going to be president or vice president, not both. So the president is out of that selection pool. We only have 11 people left to pick from. When we're filling in our third role, we are down to 10, then 9, and then 8. So the fundamental counting principle says we have 12 times 11 times 10 times 9 times 8 different ways to fill out this role in this committee, which works out to a mere 95,040 possible options. It's a surprisingly large number of ways to fill out most committees. But we'll also see that there is a distinct pattern here. That 12, 11, 10, 9, 8 multiplying descending consecutive integers is a lot like that factorial definition we just had. In fact, if we had 12 factorial, then that would produce this if we could cancel out the 7 times 6 times 5 times 4. And that's what we've got here. So if we had 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1, and then we divide that just by the 7 times 6 times 5 times 4 times 3 times 2 times 1, almost as though we're filling out 12 spaces in the committee and then scrapping the last 7. That would give us the same result. We could cancel out those 7 in the denominator and those matching 7 in the numerator. And this is the definition of the treasurer, or the definition of the permutation we're looking for. So if we take 12 people and we want to permute 5 of them, then we have 12 factorial over 12 minus 5 factorial, or 12 factorial over 7 factorial. Now, in general, if you have n permute r, so if you have n objects and you want to take r number of those objects and rearrange them, you will have n factorial over n minus r factorial ways to do so. This is what we call the general term. So your instinct is going to say, well, we're going to call it the formula. Mathematicians like to call it sometimes the formula, but often the general term, because it applies in the general case. Not this specific case, not that specific case, but any case that comes down to permutations. So this formula here is one that we should be very familiar with. Now, some students like to just set that aside and just trust that their calculator can calculate it, which is true anytime you know all of the numbers in the problem. There will be problems that we will look at specifically in lesson 5 in which you don't know n or r, and you have to figure out what it is, and you're going to have to go to the algebraic definition to do it. So we will do that in more detail later. It's coming. But for now, if you know all the numbers, then yes, your calculator is the most efficient way to solve the problem in most cases. But if you don't have all the numbers handy, you need to understand this so that you can fall back on it and still solve the problems at hand.